Class 12 physics. In the last few lectures, we discussed about the electromagnetic induction. As an application of electromagnetic induction, we also discussed the working, construction, and principle of an AC generator. I think all of you are familiar with the output waveform that obtained from the AC generator. That is nothing other than a sine function. That is a function continuously varying with respect to time. The electric main supply in our home and office is also a voltage that varies like a sine function with time. Such a voltage is called alternating voltage or AC voltage. The main reason for preferring use of AC voltage over DC voltage is that the voltage can be easily and efficiently converted from one voltage to other by means of transformers. Don't worry, we will discuss about transformers at the end of this chapter. The electric main supply in our home is 220 volt 50 Hz, where 220 volt is the voltage and 50 Hz is the frequency of the AC signal. Don't misunderstand that the AC is always a very high value. There is no restriction like that. Only the criteria for a signal is said to be AC is that nature of variation. Any signal obeying the equation of a sine wave is said to be an AC signal, irrespective of the frequency, amplitude, and phase, etc. Okay, I think we can look into the syllabus first. The topic we are discussing today is 7th chapter of class 12. Chapter 7. Alternating current, or it can be abbreviated as AC. In this chapter, first we are going to discuss about introduction. AC voltage to resistor, AC voltage to inductor, AC voltage to capacitor, AC voltage to resistor capacitor circuit, resistor inductor circuit, and RLC circuit. Then analysis of RLC circuit in detail. Then power in an AC circuit. In this analysis, we discuss about resonance, quality factor, etc. Okay. Then we will discuss about LC oscillations, and then finally transformers. And after that, we will discuss about summary of the chapter. We will just discuss about the summary of the chapter, and then problem solving. I will try to solve as many questions that possible. That is just because if you are able to solve problems in this chapter, that means you are a master in this subject. It is AC's question from AC can be asked in different types. I will try to solve as many questions that I can possible. Okay, I think we can start. The discussion. First, symbols use. Symbols that we are going to use in this chapter. First, AC voltage source. AC voltage source is represented by a symbol like this, and V is equal to Vm sine omega t. This is the general description of an AC signal, or more generally, V is equal to Vm sine omega t plus phi. Okay. try to understand the different terms. Uh, is voltage at any time t. This Vm is the maximum voltage of AC, and the factor inside the sign is called phase. Phase, or in this phase is this phase. Okay, omega is the angular frequency. See, t is time, and Vm is the maximum voltage or peak voltage, peak value of the voltage. Okay, this is about the voltage source, AC voltage source. In DC, we are just representing DC symbol by plus minus. This representation is not possible in AC. What is the reason? The reason is that in AC signal there is no positive and negative terminals. The voltage is varying continuously with respect to time. If the positive half cycle, this may be plus, and negative half cycle, this may be plus, and we can discuss that in detail as we move further. Okay, let us try to understand the waveform. Let us try to understand the waveform of AC. In x-axis, we will mark omega t. In y-axis, voltage. Okay. The maximum value of voltage is Vm. Minimum value, this is minus Vm. Okay. We know that this is pi, this is 2 pi. This value is pi by 2. This value. Okay, this is I think this is clear from your trigonometry understanding. And if you have some doubts on it, you please refer your class 11 trigonometry and look into the waveform of sine function. Okay. The variation need not be in the term of voltage. This also can be in the form of current. If the variation is plotted in terms of current, in y-axis it is current, this x-axis omega t, pi, 2 pi. Maximum value will be not Vm, it will be Im, and minimum value will be minus Im. One important thing that is to be noticed that at omega t equal to 0, pi, 2 pi, omega t equal to 0, pi, 2 pi, the value of V equal to 0, and omega t equal to pi by omega t equal to pi by 2. Therefore, the value of V is equal to what? Maximum, or at this Vm minus Vm. Okay. That is about the source. Then next, resistor. Symbol is R, represented by this symbol. This is a two-terminal device. R. Unit is ohm. Resistor R. And remember one thing: resistor is a device which obeys Ohm's law. The symbol of resistor is like this. Next, capacitor. All this you are familiar in the chapter 2 and chapter 3, but just for introduction, I am just giving the symbol only. Capacitor is also a two-terminal device which is represented by capital C. What is the unit of capacitor? Farad. Then inductor, represented by L. The inductor is also a two-terminal device, and the unit is what? Henry. The unit of resistor is ohm, capacitor is farad, and inductance is Henry. One important thing you need to understand that resistor is a component, and Inductance is the property of the component, and capacitor is a component, and capacitance is the property of that component, and inductor is a component, and inductance is the property of that component. Okay, the unit of resistance is ohm, unit of capacitance is farad, unit of inductance is Henry. Okay, I think it is clear for you. Okay, then some other symbols. What is the symbols for bulb? A bulb is represented like this, and bulb is described represented with B, and the watt power dissipation in the bulb is in watt. Example 100 watt bulb, 60 watt, or 40 watt, etc. Described like this, and the voltage 220 volt, 100 watt, like this. Okay, bulb. And symbol for antenna. What is symbol for antenna? This is the symbol for antenna. Not just any. This is used rarely in this chapter for describing the reception of a radio signal using an important property that we are going to discuss in this chapter. Okay, these two symbols we are using rarely in this chapter, but the above four symbols we will use throughout this chapter. Okay, let us try to understand what is. This is P is equal to Vm sin omega t. What is omega? What is omega? Omega is the angular frequency. Okay, this is called this is like that. This is one cycle. This is another cycle. This is another cycle, and this is called positive half cycle, and this is called negative half cycle. This is called positive half cycle, and this is called negative half cycle. And this is that we are already discussed, positive peak, and this is negative peak of the alternating voltage. Okay, then what is omega? Omega and F. Consider an example. Consider a signal 220 volt, 50 hertz signal. What is hertz? Hertz is 1 by second. Okay, that means here F is 100 hertz, or in 1 second, there is 50 cycles. What is omega? Omega is 2 pi f. In this particular example, f is 50 hertz, so 2 pi into 50, that is equal to what? 100 radian per second. 100 radian per second. That means in 1 second, this is pi, this is 2 pi. In 1 second, the sine wave has, in 1 second, it 100 pi. At 1 second, it will cross 100 pi, and another 1 second, it will be at 200 pi, and end of another 1 second, it will be at 300 pi, etc. For to understand, we can consider a signal f is equal to 1 hertz, or omega equal to 2 pi f, that is equal to 2 pi into 1, that is equal to 2 pi radian per second. This is pi, this is 2 pi. Okay, this is 0. Okay, we know that omega equal to 2 pi. Therefore, f is equal to 1 hertz means in 1 second, and 1 cycle. This is 1 cycle. 1 cycle. In 1 second it will complete 1 cycle, and another 1 second it will complete 1 cycle, and like that. Actually this is 2 pi into 2 pi in omega t. Omega t means 2 pi into 0. Here 2 pi into 1 by 2 in 0.5 second. In 0.5 second it will cross pi. This is 2 pi into 1. This 1 by 2 is second. This 1 is second. The 2, that is 1 second. And the but 1 second it will be at it will cross 2 pi radians. 2 pi radian. Understand? 2 pi into 0, 2 pi into 0.5 second, 2 pi into 1 second. And at 1.5 second, what will be the value? 1 second it will be here. 0.5 second it will be here. And at 1.5 second, 2 pi into 1.5. Okay. And 2 second, 2 pi into 2, that is 4 pi. Understand? Let us consider another example for if f is equal to 2 hertz. Omega will be what? Omega will be 2 pi into f, that is 2 pi into 2, that is equal to 4 pi. 4, it is equal to 4 pi radian per second. 4 pi radians per second. Okay. In this pi, 2 pi, 3 pi, 4 pi, etc. Here omega t is in x-axis. Omega t equal to what? Omega t equal to omega is equal to 4 pi into 0 here, and here it will be 4 pi into, is it 0.5? Not. The value is pi. To get pi, 4 pi should be multiplied with 1 by 4. That is 0.25 seconds. That is t is equal to 1 by 4. The value will be here. And at 4 pi into something should be 2 pi. What will be that? 1 by 2. At 1 by 2 second, the value of voltage will be here. And 4 pi into, answer should be 3 pi. What should be that? Something into 4 pi into some value should give 4 pi into x equal to 3 pi. Okay, x equal to pi and pi will cancel. X equal to 3 by 4. Okay, 3 by 4. And what will be 4 pi into 1? Okay, at 0.25, I can use a different color for better understanding. 0 second. 0 second sign will be at 0. This is 0.25 second. This is 0.5 second. This is 0.75 second. This is 1 second. That means this is 0 second. That means in 1 second, sorry, let me erase. In 1 second, it will complete, 4 pi radians. In 1 second, it will complete 4 pi radians. That means omega equal to 4 pi. Or in 1 second, it will complete 2 cycles. Therefore, f is equal to 2. If it is expressed in angle, that is angular frequency. That is 4 pi. If it expressed in terms of number of cycles, that will be frequency f. I think the difference between f and omega is clear for you. Okay. If you have any doubt, please drop a comment on the comment box. I can explain it to you for. I can explain it in next video also. That is, these concepts are very important for understanding AC signals. Okay. E is equal to Vm sin omega t. This is a general equation of AC signal, and omega equal to angular frequency. Omega equal to 2 pi f. Omega is, unit of omega is radian per second. Unit of this equation is important. F is frequency and unit is hertz, or 1 by second. Hertz is equivalent to 1 by second. Okay, this equation is important. You must remember this equation for exam point of view, and I think the concept is clear. And f, unit of f is hertz and unit of omega is radian per second. In a question, if they give frequency in radian per second, you should understand that that is angular frequency. If the value is given in hertz, that means that is f. Okay, you should be able to distinguish between omega and f. Another, t is equal to time period. Time period means this is time. This is time period at here, and what is the time period here? This is time period, and this is another time period. That is time required to complete one cycle is the time period. Here time period t is equal to what? T is equal to what? 0 second, 1 by 2, it is 1 second. And here time period t is equal to 0.5, 0 to 0.5, 0.5 second. Okay, t is equal to time period, and t is equal to 1 by f. That is equation for time period in the terms of frequency. Here f is given as 1 hertz, then t is equal to 1 by f is equal to 1 by 1 is equal to 1 is equal to 1 second. And here f is equal to 2 hertz, t is equal to 1 by f is equal to 1 by 2. Okay, that is 0.5. Okay, I think the concept is clear. If f is equal to 50 hertz, omega equal to 2 pi f, that is equal to 100 pi. That means this is omega t, that this is voltage or current. In 1 second, it will complete 50 cycles, or it will complete 100 pi radians. Okay, 1 second. This is 1 second, not 1 cycle. 1 cycle is this. This is 1 cycle. Time period is t. T will be what? 1 by 50. 1 by f. That is 1 by 50 second. Okay. I think the basics are clear, and this is very required for understanding the AC voltage applied to a resistor, AC voltage applied to a capacitor, AC voltage applied to an inductor. In next, we are going to discuss about different AC circuits. First, AC voltage applied to resistor. AC voltage applied to resistor. Consider a source and a resistor is connected to that resistor of value R, and voltage, let me write here, V is equal to Vm sin omega t. That is the value of resistor. That is the value of resistance. That is the value of voltage source. R is the value of resistance. While voltage is varying sinusoidally with respect to time, V is equal to Vm sin omega t, and a resistor is a device which obeys Ohm's law. Therefore, by Ohm's law, I is equal to V by, or we can use capital letter I. Usually capital letter I is used for representing DC current, and small letter I is used for representing AC current. But if I use capital I, if I use small I for representing current, it will make confusion during the problem solving section between 1 and I. So I am using capital I for representing AC current. So Vm sin omega t by R, that is equal to Vm by R sin omega t. Okay, that is Vm by R into sin omega t. We can take Vm by R is equal to Im. Then I will become Im sin omega t. Okay, this is voltage equation. This is current equation. In resistor only circuit, voltage V is equal to Vm sin omega t, and current I is equal to Im sin omega t. Okay, Here phase of voltage is omega t and phase of current is also omega t. That means phase of voltage and current are equal, or in general voltage and current are in phase. Voltage and current are in phase. If we represent that graphically, sorry for the bad drawing, but you should understand with this. Okay, I think I can make another one. This is very bad. You can use a different color for representing current. Okay, this is Vm sin omega t and this is Im sin omega t. Here at the same time they will start to grow, and at the same time they will reach the maximum value, and at the same time they will cross zero. Okay, that is why we can say the voltage and current is in phase. They will start at the same time, they will reach the maximum value at the same time, and they will again cross at the same time, and again reach the negative peak at the same time, and again cross the zero at the same time. At every point this will satisfy. If a circuit is only contain voltage, alternating voltage source and a resistor, the voltage waveform and current waveform will be in phase, or there will not be any phase difference between the voltage and current. Okay, let us take a value. If V is equal to 5 sin omega t and I R is equal to 5 ohms, then I is equal to 5 by Vm by R, 5 by 5 volt by 5 ohm into sin omega t, that is equal to 1 sin omega t. Voltage is 5 sin omega t, current is 1 sin omega t. This is 5 sin omega t. If we draw current in the same diagram, I'm sorry, this is 5 volt, sorry, not 5, this is 5 volt, and this is voltage and this is current. 5 volt. Here this is not 1 volt, this is 1 ampere. We are using same coordinate system for representing two values. We are using same graph for representing voltage and current. That will be like this. In this case, R is 5 ohm. That is R greater than 1. R greater than 1. Therefore, current is below the voltage. If R is less than 1, V by a point something, a value less than 1 will be, that is will be I, and I will be greater than V. If R is less than 1, the current will be above the current magnitude will be above the voltage magnitude. Okay. In this case, R is 5 ohm. Therefore, we draw that below voltage. Okay. I think this is clear.